Good morning, everybody. Today I will tell you about screening. In my previous lecture, I have talked to you about the particle technology. In particle technology, we have studied about the particle size and shape. We have done the size analysis and then we calculate the different parameters such as ds bar, dw bar, dv bar, number of particles, average surface area, and the sphericity also. So now I will tell you what is screening. Student, screening is basically a method which is used to separate particles on the basis of their sizes. मीन्स स्क्रीनिंग में हम पार्टिकल्स को सेपरेट करते हैं उनके साइज के बेसिस पे. वी कैन डन इट मैनुअली और बाय यूजिंग अ स्क्रीन. The particles are separated on the basis of oversize and the undersize. Before I tell you about screening, I want to introduce a term that is called a MASH. Now here comes the thing that what is MASH. Technically, MASH is the number of openings per linear inch. If I say that there is a 10 MASH number screen, then it means the screen is having 10 openings per linear inch. तो बेटा अगर हमें पास दो स्क्रीन्स हैं, एक स्क्रीन है आपकी 10 मैश की और दूसरी स्क्रीन है आपकी 100 मैश की, और आपसे मैं पूछूं कि आपको किससे फाइन पार्टिकल्स मिलेंगे, सो योर आंसर विल बी 100 बिकॉज 100 मैश मीन्स देयर आर 100 ओपनिंग्स इन वन लीनियर इंच एंड 10 मैश मीन्स देयर आर 10 ओपनिंग्स पर लीनियर इंच. सो ऑब्वियसली जितनी ज़्यादा ओपनिंग्स होंगी उतना साइज आपका छोटा हो जाएगा. So particles which are retained over the screen are known as oversize and the particles which passes the screen are known as undersize. तो यहाँ पे हमारे पास दो नई टर्म्स और आई. देखिए ओवरसाइज क्या होता है और अंडरसाइज क्या होता है. जब भी आप स्क्रीन के थ्रू पार्टिकल्स को सेपरेट करेंगे तो कुछ पार्टिकल्स उसमें से पास हो जाएंगे और कुछ पार्टिकल्स उसके ऊपर रह जाएंगे. जो पार्टिकल्स उसमें से पास हो जाएंगे दैट आर नोन एज अंडरसाइज और जो पार्टिकल्स ऊपर रह जाएंगे दैट आर नोन एज ओवरसाइज. अब ये जो आपकी स्क्रीन होती है ये होती किस चीज़ की है. दिस स्क्रीन कैन बी ऑफ वायर, कैन बी ऑफ क्लॉथ. जो आप मैकेनिकल ऑपरेशन में यूज़ करते हैं, आप लोगों ने अपनी लैब्स में भी देखा होगा, दैट स्क्रीन आर ऑफ मेटल वायर्स और वहाँ पे हम उसे मैश बोलते हैं. फाइन. नाउ व्हाट आर द ऑब्जेक्टिव्स ऑफ द स्क्रीनिंग. स्क्रीनिंग इज बेसिकली डन before entering the material into the equipment. It is necessary to remove the fines or degradation from the finished product or to scrap out the oversized material. Now here we apply the material balance on the screen. By material balance we means that we apply the material balance equation which states that input minus output plus minus appearance or disappearance equals to accumulation. For steady state we consider accumulation equals to 0. And we assume that there is no appearance and no disappearance. So by putting these values we will obtain the equation input equals to output. Now here we consider a MASH. हमारे पास एक स्क्रीन है जिस पे हमारी फीड एंटर कर रही है F और उसका जो ओवरफ्लो है that is D and the underflow is B. Now I have applied the overall material balance. Overall material balance means total input equals to total output. So you can see from the diagram that total input is F and output is D and B. So total material balance will be F equals to D plus B. That is equation number 1. Now I apply material balance for equation for material A. For material A, I will obtain F dot XF equals to D into XD plus B into XB. Now I will solve these two equations and obtain the two ratios D upon F and B upon F as mentioned in the equation 3 and 4. Now next is screen effectiveness. That what is screen effectiveness? By effectiveness we generally talk about the efficiency. So efficiency means how much product is obtained with reference to the reactant. So basically screen efficiency can be described on the basis of oversize and undersize. On the basis of oversize it is expressed as EA and on the basis of undersize it is expressed as EB, and the total efficiency can be given by EA into EB. So EA can be calculated and it is given by D into XD upon F into XF, while EB is given by B into 1 minus XB upon F upon 1 minus XF. We multiply this equation and we obtain the required equation for the overall efficiency, that is capital E, which is equals to EA into EB. Now there are some major screening equipments. Major screening equipments include grizzlies, gyratory screens and the vibratory screens. All these screening equipment differ due to the motion we have provided. In the gyratory screens, we provide gyratory motions. In vibratory screen, we provide vibratory motions. So basically there is a difference in the motion we are providing for separating the particles. Now there is ideal and actual screen. Generally ideal means that when all the conditions are perfect. But in real situations, all the conditions can't be ideal. So ideal screens are virtual. In actual practice, only real screens are actual screens are available. You can see from the diagrams the difference between the ideal screen and the actual screen is clarified. An ideal screen is one which sharply separates the feed mixtures in such a way that the smallest particle in overflow is just larger than the largest particle in the underflow. Means there is a sharp separation, there is a cut diameter. While in the actual screening, no such condition exists. So there is a difference between ideal and the actual screen. I hope you are able to understand that what is screening, what is MASH, what are the screening equipments, what is effectiveness, what is screen effectiveness, and how we can calculate the total screen effectiveness. Students, this first unit of mechanical operation includes particle technology and screening. So first unit is completed. Here are some numericals which I have given for the practice. I will tell you about them also. So, like in this numerical, you have to calculate the sphericity of a conical solid of diameter 2 mm and height 5 mm. We know that the sphericity is 6 Vp upon dP into Sp. We put the figures and we will calculate the sphericity. Thank you so much. If you have any doubt, you can just comment and ask. Thank you.